Okay, AP Physics C, I just want to quick introduce this worksheet to you. So objects moves with the following velocity. So it's two-dimensional motion, Vx and Vy. All right, so Vx, we see a nonlinear acceleration because it's proportional to t squared. Vy, we see a linear acceleration. So this is, you want to kind of interpret this, right? So this is basically, if you think about this, this would be the acceleration. This is V naught. This is 1/2 the jerk or rate of change in acceleration. It's always useful to try to analyze that a little bit. Sometimes you can, sometimes you can't, right? If you have cubed functions in here, then that gets wacky. Determine the acceleration of the object in each direction in terms of t. Okay, so ax equals the derivative of vx with respect to time, right? Ay also equals the derivative of vy with respect to time. That's how you go about doing that. So you're doing it in each direction. All right, so Vx with respect to time ends up being 6.0 t, and Vy, Ay ends up being -10. And the units on both of these would end up being meters per second squared. It should probably say something in the directions about that. Assume that units give you meters per second squared. Now the next question about determining displacement in terms of t, well, you're gonna integrate this from 0 to t. So delta x is the integral from 0 to t of 3.0 t squared plus 4.0 with respect to time. I'll write the delta y over here to give myself a little space. From 0 to t. We do it from 0 to t, so then you can just plug in any t you want and get the displacement from 0 up to that time. All right, so -10 t dt. So follow through with the integration. I'll do one of them for you here. I'll do the delta y because that's the easier one. All right, so -10 t squared over 2 evaluated from 0 to t. So I literally am plugging in t for t. Ooh, so delta y from, and keep in mind this from 0 to t is -5 t squared. All right, so the object starts in xy coordinate of 0, 0, moves for 5 seconds, determine the object's final velocity and position in each dimension. So you're going to figure out the final velocity, so you just plug in 5 for t, and the velocity, and then you're going to figure out the final position. So you figure out the displacement in each direction and just add that to 0 in each direction, or the initial position. I'm surprised I didn't have you try to make a sketch of that in this first worksheet, but maybe I do that. I do that on the back. Sketch a diagram of the object's motion. All right, so what you're going to do there is kind of think about plotting points, right? I would go like this, right? Because it's going to move negative y direction, right? Negative y, positive x, right? So try to draw what that path is going to look like. Magnitude of the object's displacement. All right, so this is overall displacement. So object starts here, ends here, right? The displacement is the straight line distance. Well, you're going to know delta x and delta y. So the overall displacement, we'll call it delta r, is square root of delta x squared plus delta y squared. So the magnitude of the object's displacement. Now, let me show you this. The magnitude business is interesting. When you have a vector quantity, like a displacement vector, and you want its magnitude, you either write the absolute value, you put the little vector symbol over it and take the absolute value of it, but it's implied that you're dealing with magnitudes if you don't put the vector symbol over top. It's implied that you're dealing with the magnitude of the vectors if you don't put the little vector symbol over top. All right, magnitude direction of object's velocity relative to positive x-axis. So what that means is relative to positive x-axis, that means give me an angle relative to that axis. All right. Number 2 is pretty much more of the same. See what we can do there. And then number 3, we'll start rotational motion. So just a little practice of multidimensional motion and calc functions, okay? Nothing too hard. Do your best with it. All right. I'll talk to you later.